Well, welcome back, you guys. We're going to take a look at cylindrical shells today. So the next method for finding volumes, and it will use what's referred to as cylindrical shell. So let's see if we can't see this set up here. So what we're going to do is we're going to take this, consider this rectangle as shown in the figure here, and we're going to notice this rectangle is parallel to the axis that we're revolving it around. So if you imagine the horizontal axis of revolution here, where W is the width, H is the height of the rectangle, and P is the distance between the axis and the center of the rectangle. So if you were to revolve this to this point right there, right, then you would have, actually, let me go to the outer edge, right? So if I revolve a whole thing around to there, right, then the volume would be pi, that radius squared, and then that height given by h, right? And then we're going to subtract out. Now we're going to subtract out the whole. So we'll go to there, right? So this distance is P minus the W over 2. Again, the P is right in the middle of that width there. Okay. And so if we subtract that out, right, the volume of the hole, and clean that all up, you'll have 2 times pi times the average radius. Okay, so that P is, let me do it in blue, the average radius, right, that's the P, right to the middle of that rectangle. Average radius times its height, here's the height, from there to there, times its thickness, W. Okay? And then we're going to run a limiting process on that. Okay, so that's the cylindrical shell. And so we run that, 2 pi radius. Again, we run that limiting process so as that thickness, if you will, goes to 0, or as the number of those cylindrical shells go to 0, right? So it goes to infinity, sorry, same thing. We run this limiting process. Then what we end up with is our shell method. So 2 pi, and I'm going to write it as our shell radius times our shell height, and it's right here. Okay, that's to do it, to revolve it about. All right, so here's our 2 that we'll use. We'll do it first, revolving it around. We'll do it with respect to the x, so we'll revolve it. I'll give you some pictures here, but we'll revolve it around a vertical line initially. Okay, so we'll do this one first, the vertical axis of revolution. Okay. All right, so let's see if we can't picture this. So here's y equals x minus x cubed drawn. And we're going to find the volume of solid of this region is bounded by that and the x-axis. So we've cut it off with the x-axis. There's the region bounded with the equation and the x-axis there. And we're going to revolve it about the y-axis. So we're going to revolve it around the y-axis. So revolve it about a vertical line. So we make our rectangle parallel to the axis of revolution now. There's that thing parallel, right? You see how it's parallel to our vertical axis of revolution? And we're going to spin that around. So if you can imagine, all right, this is spun around, if you can imagine. I can't draw these things at all, but spun around. That whole thing spun around, right? You can imagine that volume, right? and that'll give you that three-dimensional object. Does that make sense? And we're summing up all those shells, right? Summing them all up. And so our formula is 2 pi shell radius times shell height with respect to x, from x being A up to x being B. Okay? Now I am going to erase the mess I made here for a minute so that I can show you the shell radius and that shell height. That's okay. So the shell radius, if you can see from there to there, is just how far out x am I. That's my shell radius. Okay. And now the shell height, here's our shell height, right? That's whatever that y value is, right? Depending on how far out x I went, it's how high the y is. So in this case, it's just x minus x cubed, the equation. It's the y value. And then we're summing all these shells up, right, that are being spun around. We got all these shells being spun around, right, summing all these things up from an x value of 0 out to an x value of 1 where it hits again, the other x-intercept, from x being 0 to x being 1. So we got 2 pi, we got x squared minus x to the 4th dx 0 to 1. So you got 1/3 minus 1/5. Let's see, that's 5/15 minus 3/15, so 2/15, so 4 pi 15ths. And then let's do another one there. So here we've got a quadratic. We got 1/2 x squared plus 1, right? Here's part of that. 1/2 x squared plus 1. We got y equals 3 and x equaling 0, right? So there's our bounded region. We're going to revolve this thing about a vertical axis again, in this case about the y-axis. And so we'll cut it parallel to the y-axis. There's our cut. And of course we're going to spin that. So if you can imagine, right, this is being spun, right? And of course that part right there is being spun. So that's kind of the shape of this one. And let me remove the shape part so that I can, we'll do the shell radius and then the shell height with respect to x here from A to B. And so you're going out x distance again. There's our shell radius, right? Again, this thing's being spun, right? And then the shell height here would be, here's our height. So it goes from a y equaling 3 minus, and then that is our 1/2 x squared plus 1, right? So it'd be, the height would be 3 minus that curve. And then from an x value of 0 over to, we haven't addressed this yet. Let's make sure, it looks like it's 2, but where do they intersect? Where's the intersection of 1/2 x squared plus 1 and y equal 3? Where do they hit? So 1/2 x squared, subtract 1 on both sides, I got 2, multiply by 2 over 1, so I got x squared equals 4, so that looks like they hit at plus or minus 2. Of course, this would be the x value of 2, so they go up and they hit at 2. So we're going to sum it up from 0 to 2, and then let's go ahead and finish this. Two minus 1/2 x squared. Two x squared over 2 minus, now that'll be x to the 4th over 2 times 4 is 8. Four minus 16 over 8 is 2. So it looks like we got 4 pi. Units cubed. All right, this next problem would be a good you try it problem. So go ahead and pause it, give this thing a shot, and then we'll work through it. So here we've got the region bounded, and we've got y equals x squared in blue here. If you're not sure, you could plug in like 1 and make sure you got 1, 1 there, right? And then I've got pictured here that 4x minus x squared. You can see how they're bounded. And by the way, where do they hit? Where's their intersection? Where does x squared equal 4x minus x squared? So add x squared to both sides. You got 2x squared equals 4x. I'm solving a quadratic here. So get one side equal to 0. Let's go ahead and factor out a 2x. So I have 2x equals 0, and x minus 2 equals 0. So they hit at 0, and they hit again up here at 2. Is their intersection, right? And let's set this up. So we're going to take, this thing's going to be revolved about the y axis. So we slice it parallel to that y axis so that we can spin that cylinder around, right? So we spin that thing around, and we're spinning all of these things around. So if you could draw it, I can't draw these things, but anyways, I'm trying to draw that thing being spun around, right? All those cylinders being added up. So let's go ahead and do the shell method. I got 2 pi shell radius, shell height from A to B. And let me get a little room here. My radius is out x amount. So I got 2 pi integration. There's my radius. My height is the red minus the blue. So top minus bottom would be the shell height. So in this case, it'd be 4x minus x squared minus the bottom, which is x squared. And we're going from x being 0 up to x being 2 as our bounds. So we got 2 pi x 4x minus x squared minus an x squared, so that's minus 2x squared. So 4x squared minus 2x to the third, 0 to 2. So we got 2 pi, let's go ahead and integrate that, 4x to the third over 3 minus 2x to the fourth over 4, 0 to 2. Looks like I got 0 minus 0 again there. So we got 2 pi we got 4 times 2 to the third, so we got 32 over 3 minus 2 to the 4, 16 over 2 is 8. But let's get a common denominator, so that'd be 24 over 3. So 32 over 3 minus 24 over 3 give us 8 over 3. So our volume here would be 16 pi over 3 cubic units. All right, so here's another you try. Go ahead, pause it and work through that sucker. We'll work it out in a sec. Go ahead and draw this thing. We've got a line x equaling 4. There's x equaling 4, but let me go out. Let me do the square root up to that. So here's the square root function. And the y-axis is the bottom of this. So that's the region bounded. And we're going to spin this about the y-axis. I'm going to spin it about the y-axis. So I'm going to cut it parallel. All right, this is our axis of revolution. So I'm going to cut it parallel to it. And I'm going to spin that. So we'll have that cylindrical shell. So again, if you can imagine over here, right, these are all being spun, right? The whole thing. Oops, that's terrible. Anyways, you spin that, you get that kind of that whole sinking hole there in the middle of that thing. That's the visual on that. And so for each of these shells, right? So we've got all these shells being spun and being added up, right? All those being added up. But I can't draw worth beans, so let me erase this so we can show our shell radius. So the radius out to the middle of that rectangle is x. There's our shell radius. And our shell height is just square root of x minus 0. Right, down to y equals 0, so just square root of x, right? So we got 2 pi, we got a shell radius, our shell height is top minus bottom, square root of x minus 0. And then we're summing it up from x being 0 up until x being 4. 0 up until 4. Okay? Well, x times, this is x, square root of x is x to the 1/2. Product property, exponentials, 1 plus 1/2 is 3/2. Now we're going to, so that'll be x to the 5/2 all over 5/2, so 2/5. So 0 up to 4. Throw the 4 in. Throw the 0 in. So that's 2 pi, 2/5. I'm going to write that. That's square root of 4 to the 5th. You see that 4 to the 5/2? That's just 0 over there, so that's gone. So we got 2 pi. I got 2/5. Square root of 4 is 2. 2 to the 5th is 32. So we got 64/5 times 2 pi. So our volume here is 128 pi over 5 cubic units. So this last one with a vertical axis of revolution, at least for this one, is revolving about x equaling 6. So it's that same visual down, y equals root x. X equals 4. Y equals 0, right? So here's the region. Again. But this time, we're going to revolve at about x equaling 6. Okay, we're going to revolve at about x equaling 6 this time. So we still slice it parallel to x equaling 6. Slice it parallel. And actually, let me, volume is 2 pi, shell radius, shell height, a to b. Okay. And so we're still going to sum it up from 0 to 4. That'll be our bounds on this. Still sum up those shells from 0 to 4. Visually, what's going on, if you can imagine, right, this is all being spun, right? So we've got that hole in the middle, right? So let me erase this real quick, and then we'll walk through what's our shell radius and our shell height. Okay, so here, what we have is our radius of this being spun. That's our radius. And so it's right minus left. X equaling 6 minus, remember this distance is x, so 6 minus x. That's our radius. That's our radius. The height is still the square root of x. Right, so it's taking all these, remember it's spinning all these around and summing all those up. And we're ending at that x value of 4. So it's just spinning it. So it takes care of the whole, if that makes sense. So I got 6 root x, or 6x to the 1/2, x times x to the 1/2, x to the 3/2, 0 to 4. So we got 2 pi 6x to the 3/2, all over 3/2, so times 2/3. I need to put it right there. Minus x to the 5/2 all over 5/2. So it's like I got 12 over 3. That's kind of driving me nuts. Let me just erase that and make that a 4 right there. And then let's go ahead and plug that in. 2 pi, 4, 3/2, 4 to the 5/2. 0 minus 0 on that. So 2 pi, 4 times, well, 4 to the 3/2, that's 4 to the 1/2, so square root of 4 to the 3rd, so 2 to the 3rd is 8. So we got 4 times 8, 32. Oops. Minus 2/5, so I got 4 to the 1/2 is 2. 2 to the 5th is 32. So we got 32 minus 64 over 5. Let's see, 32 times 5 is 160. So we got 2 pi 96 over 5. So our volume is 192 pi over 5. All right, let's do one now with a horizontal axis of revolution. So this one's going to go about the x-axis. You can see my little arrow there. We're going to spin it, and so we want to slice it parallel to that horizontal axis of revolution. And our bound is, so here's our x being e to the negative y squared. So x is already, it's already solved for. X is in terms of y, so that's nice. And that's already solved for that curve. You've also got y equaling 1 on top. There's that top bound. X equaling 0. There's the bound on the left. And the y-axis y equals 0. I'm sorry, the x-axis, y equals 0 on the bottom. So it's that piece spun around the x-axis, right? And so our shell radius would now be the y. You see that? It's that y height is our radius now, right? Because this is being spun around, right? So that's the radius, average radius there of that shell, cylindrical shell, right? And then the height would be right minus left. Well, the right-hand side is e to the minus y squared minus x equaling 0. So it's just e to the minus y squared. Right minus left is the height. E to the negative y squared. There's your height. Let's write it out. Volume is 2 pi. And then from C to D, shell radius, shell height. When you do this with a horizontal axis of revolution, you will do it with respect to y. That's why we have the C and the D there. Shell radius is the y. Shell height, x equals e to the negative y squared. Again, right minus left on that. From y being 0 up to y being 1. If you notice on this, we're going to have to do a little u sub here. So we're going to have to let u be that negative y squared. So du is negative 2y dy. So I need a negative 2y. Let me give it a negative 2. I have to give it a negative 2, so I got to offset it with a negative 1/2 out front. So it looks like we have negative pi 2y dy e to the negative y squared. 1. Y being 0 to y being 1. And so we got, let's run it now, negative pi. The integral of e to the u is 1 over ln of e, which is just 1 over 1. E to the u. Well, u is negative y squared from 0 to 1. So we got negative pi e to the negative y squared from 0 to 1. So I got e to the negative 1, so that's 1 over e to the 1. I got a plus pi, and notice I have that as times e to the 0. Well, e to the 0 is just 1, right? So I got negative pi 1 over e plus pi times 1. Let me do that as pi minus pi 1 over e. And so if I take a pi out, I would have 1 minus 1 over e on that. Or you punch that in. Pi 1 minus 1 over e. There it is, 1.986. We'll round it to. Well, I like the exact form. Either of those work. All right, let's move on. So we've got that same bounded area, y equals root x, y equals 0, x equals 4, but this time we're going to revolve it about the x-axis with the shell method, still with the shell method. So I'm going to ask you guys to try this one again on your own. So go ahead, pause the video, and we'll work through it in a second. So we've got the region here graphed. We're going to revolve this about the x-axis. We want to slice it parallel to that, and hopefully you can see that so well, if I was to try and draw this, right, that's that shell being spun, but this whole thing, of course, is all those are being added up, right? All those shells are being summed up, yeah? So that's kind of the picture of that. Let me erase this junk now. So we've got this shell radius, which is the y, right? And then the height would be the right-hand side, so 4, right? 4, the right-hand side minus, but I got to solve this y equal root x. I got to solve that y equal root x. Let me solve that for x here. So x equals y squared. So it's 4 minus y squared. That's your shell height. 4 minus y squared. So volume 2 pi, shell radius, shell height, dy from C to D. Shell radius is y. The height again is 4 minus the y squared, dy. And then we're summing it from y being 0 up to a y value of 2. So we got 4y minus y cubed dy from 0 to 2. So we got 2 pi. I got 4y squared over 2 minus y to the 4th over 4 from 0 to 2. So we got 2y squared minus 0 to 2. So that's all gone. So the volume is 2 pi, 2 times 4, we got 8 minus 16 over 4. So I got 2 pi times 4, so volume 8 pi. We got a horizontal. This is another great you try it problem. We'll go with the absolute value of x. Let's get the visual on this thing. Absolute value of x. And we got y equals 1 on top of that thing. This is y equals 1. I'm going to revolve this about the x-axis. So another horizontal axis of revolution. Great time. Go ahead and make sure you pause it and you try this thing on your own as you slice this parallel to that. So let's get the visual on this thing. We're spinning that, right? So down here, all these being spun. So you can see you got that kind of that hole there in the middle. And then let's talk about our shell radius is y. And then the shell height is from here minus here. Well, this is, if you think about the absolute value of x for a minute, what's the absolute value of x? Definition is it's x when x is greater than or equal to 0, or it's the opposite of x when x is less than or equal to 0. In other words, here's the line y equaling x. Over here is the line y equaling negative x. And those two make up, of course, it's x when x is greater than or equal to 0, right? And it's opposite of x. X is less than 0. So those two lines make up that absolute value. And so what you're doing is, hold on, let me erase a little bit. So if this is y equals x, this is y equals negative x. Now remember, we got to solve this in terms of x. So x is in terms of y. Over here, x is in terms of y. So I have from here minus to here is right minus left. I got y minus the negative y. And that's my shell height on that. Okay, so let's go ahead and scratch this out. We've got the volume is 2 pi shell radius shell height dy from C to D. And of course this is going from a y value of 0 up to the y value of 1. Shell radius is y. Shell height is right minus the left line. Y plus y is a 2y. So we got 2y squared dy on that. Zero up to 1. 2 pi. I'm going to run it. So let me come down here. 2 pi. Got 2. Put the 1 in. Put the 0 in. First, that's all gone. And so I got 4 pi thirds. So here's a little comparison of the disk and shell methods. So with our disk method, let's do the disk here in blue here. Here was our disk method. We always stayed, if we're spinning it about the x-axis, for example, we stayed perpendicular to that, right? In that case, we'd have a hole. Or if we do it around the y-axis, we had to be perpendicular to that, right? Our shell method, on the other hand, we're staying parallel. So we spin it around the y-axis, we cut it parallel to the y-axis, right? And we're spinning those cylindrical shells and summing them all up. So which one's preferable? Let's do this one. Let's do this in both ways and see which way we like. And when it comes to preference, it's really who's the simplest to finish off, if you ask me, right? Like who has less integration involved, which means the less integration and simpler integration I have involved, less likely I am to make an error, right? To get to my final solution. So. Alright, so we've got, here's our x squared plus 1, y equaling, oops, let me just do the part involved here. X equaling 0, y equaling 0, and x equaling 1. So that's the bounded region here. Here's my y equals x squared. And let's revolve this about the y axis, and let's do our shell method first, since we've done that a lot today. And so we'll cut this thing parallel, and that shell radius will be x, and our shell height will be that, oops, that's not x squared, that's x squared plus 1, sorry about that. That shell height will be x squared plus 1. So our volume will be 2 pi shell radius, shell height, summing it up from x being 0 out to x being 1. see, 1/4 plus 1/2. So yeah, 3 pi. 3/4. So our volume is 6 pi over 4 or 3 pi over 2. Okay. There's our shell method. Okay, now let's draw this same. Square plus 1. X equaling 1. We're going to spin this about the y-axis. So this time, here's y equals x squared plus 1. So we got to do a perpendicular, right? Perpendicular. And so this is fine. I have no hole up again spinning this, right? I have no issues if I do this up until 1, right? So my volume with the disk method, or I should say washer method, so I'm going to go this region just right there. That's that cylinder right there, okay? So I'm going to do that part first. Volume is pi integration of that. That'll be r of y squared dy from y being 0 up until that y value of 1, okay? And so what is that radius of that cylinder there? That'll just be 1, right? This is x being 1. So that's part of it. Okay. Now I've got to account for, oops. Okay, so I've done up to here, done up to there, and I've spun it around. But now I got to go from 1 to 2, which is going to have a hole in it, right? And so plus, so let me erase this. So now I'm going cutting it this way, right? So what I'm going to do first is the integration from 1 to 2 pi, and I'm going to go the whole thing as if it had no hole in it. So that would be 1 squared dy. And then I'm going to subtract out the hole. Let me see if I can draw the hole. I'm going to do the hole, so I'm going to there. Subtract out the hole. So this is solid minus the hole. And the hole is, I got to solve that in terms of x. So we got y equaling x squared plus 1. So that would be x squared equals y minus 1 plus or minus, but I have the right hand side, so it'd be square root of y minus 1. So the whole is the radius of that, square root of y minus 1 squared dy. That's the whole I got to subtract out. So let's put those two on the end together. So I got 1 squared minus root y minus 1 squared dy from 1 to 2, right? 1 to 2. So we got pi, I got 1 dy from 0 to 1 plus pi from 1 to 2 of the solid let's go ahead and integrate that. So that'd be y 0 to 1 plus pi. And I've got 1 minus y plus 1. So I got 2 minus y on this one that I'm going to have before I integrate from 1 to 2. So I got 2y minus y squared over 2, 1 to 2. And this will give us pi times 1 minus pi times 0 is pi 2 times 2 minus 2 squared over 2 minus pi 2 times 1 minus 1 squared over 2. So we got pi, that's gone, plus pi times 4 minus 2, plus pi got 2 minus a half. So we've got pi plus 2 pi minus 3 halves pi. So we got 3 pi minus 3 halves pi, which is 3 pi over 2. Same thing. So here we've got our curve here, y equals x cubed plus x plus 1. It's bounded with x being 1. It's also bounded with y being 1, but it's revolving about the vertical line x being 2 is what we're revolving this thing around. We cut this thing parallel to that, but our radius, remember this is x being 2, is 2 minus x. Remember the distance out is x. So our radius is 2 minus x. Our height here is that x cubed plus x plus 1 minus 1. Y equaling 1, right? It bottoms out at y equals 1 there. So it's just x cubed plus x. And so your setup 2 pi shell radius, here's your shell radius, top minus bottom, top minus y equaling 1 on the bottom. From an x value of 0 up to an x value of 1, right? We're going from x being 0 to an x value of 1. Over there, we're summing all those up. And so we got 2 pi, we got 2 minus x, we get x cubed plus x. Let's see, I got combine those two. (29/30). So it looks like our volume ends up being 29 pi over 15 on this one. Thanks so much for watching. See you next time.